everyone, welcome to the class. Today we'll go with the next concept, that is dimensional analysis. What do you mean by dimensional analysis? That is, today we'll go with dimensional analysis. So what do you mean by this dimensional analysis? This is one of the technique to group the variables involved in a particular phenomenon. So in brief, to explain this, so let us take an example of one car moving from one place to other place. So what is the phenomenon here? What is the process happening? The process happening is the car moving from point 1 to point 2. So let us say this is point 1 and this is a point 2. What is moving? A car is moving from one of the point to another point. So during this process, what are all the variables involved? The variables involved is, first one, the weight of the car. Second one, the length of the gap from point 1 to point 2. Third one, density of the air which is flowing over the surface of the car. It is called rho. Fourth one, self weight of the vehicle. Again, I'll take it as small wt something. Then friction in the wheel. Friction between wheel and road. So like this, I can list out so many processes, so many variables that can affect this process. What is the process? Movement of the car from point 1 to point 2. Process is very simple, but the variables involved is so many things. So if I want to solve this concept by using analytically, it is very difficult to solve because of this so many number of variables. So here in this technique or today's class, what we are going to see, we are going how to reduce this number of variables. In fact, we are not going to reduce the variables whatever is there here. We are going to group some variables to a proper group, and then totally if I calculate a proper group, and we'll name it as pi terms, like pi 1, pi 2, pi 3, pi 4. So each pi terms includes 2 to 3 variables or 2 or 4 or more variables put together to make one non-dimensional term. So that what will happen, what is the advantage of doing such process? The advantage of doing such process is, the number of variables, let us say here it is 50, it is very difficult to solve the problem. Just the problem is very simple, car is moving from one place to other place. If the number of variables involved in this process is huge, like 50 or 100, it is very difficult to solve analytically. So what we'll do, we will try to group or categorize all the variables in the form of some groups, and we'll name it as pi 1, pi 2, pi 3, where this pi 1, pi 2, pi 3, totally if I put together, it will be very, very less compared to this 50. So that it will be easy to solve the problem. Okay. So today we will not take any of the process to solve the problem. Here we are going to, today in this technique, we are going to explain only how to group the variables into a proper format. That we are going to see here. So these are all the variables. Let us say I will put rho, weight, W in one group. How to put that? There will be some ratios, no, weight by rho, like this is an example I am giving. Like this we are going to put. There is some technique to put the variables into the pi term. That we are going to see here today. So to do that, I have taken some example. The example is, the performance of a turbo machine depends upon the following variables. What are all the variables involved here? What is the process or a phenomena? The process or a phenomena is performance of the turbo machine. Performance of the turbo machine is the phenomena or the process. What are the variables involved in that? One of the variable involved in this is discharge, Q. The second variable involved in this is speed at which the turbo machine is rotating or operating. The second is the next is diameter or size of the rotor, that is capital D. And energy per unit mass, it is denoted by GH. Next, power absorbed by the turbo machine or power produced by the turbo machine, and the density of the fluid on which it is, means the fluid which is operating. So there are so many variables. How many variables are there here? 1, 2, 3, 4, 5, 6. There are 6 variables. So all these variables, I'll call this as one name called as small n. Small n indicates the number of variables involved in a particular process or a phenomena. So how to group this? So if I solve the problem by using this analytically by all 6 variables, the length of the problem may go on varying, go on increasing, and it is very difficult to finally approach the one solution. So in that, instead of that, I will try to group each and every variables or few variables in a particular group so that the number of groups will be less, and each group is called as pi terms. So instead of using these variables, further onwards we will try to use only pi 1. So pi 1 indicates that group, so that will be easy to solve the problem, attain the solution. So how to do that? Here then this is called number of variables, that is n. There are 6 number of variables. So that's all it is. There are 6 variables. So what is the technique for this question? This is the solution. What is that? First, we are supposed to make a note of all the variables and write down these variables in the form of units. Let us try to write the unit of these variables in the form of MLT form. We are supposed to write the units of these variables in the form of MLT, mass, length and time. So what is the unit of discharge? Discharge is meter cube per second, where meter cube per second is represented by L cube t to the power of minus 1. Similarly, for all the variables involved in a particular process, this is the variables involved, and this is the MLT form. Okay. Along with this, density is also involved. I will write the density here. The 6th variable is density. So the unit of density is kg per meter cube. And if I want to represent this in MLT form, this will be m L to the power of minus 3. So this is the variables which are represented in the form of MLT. So now we will see how to solve the problem. So the next step what we are supposed to do is, we are supposed to categorize this as repeating variables. We are going to select the repeating variables. Repeating variables. So how to select these repeating variables? One, while selecting the repeating variables, we are going to select the repeating variables based on fluid property and dimensional and kinematic. Or we can call it another way, you can call it as first one, geometric variables, kinematic variable, third one, dynamic variable. Where geometric variables, what should be included? It should be included the term called L. Kinematic variable which should include only T term, and dynamic variable which should include the mass term. Mass, and this is time, and this is length term supposed to be included. So based on that, I am going to select the repeating variables. So for this particular problem, what is the repeating variables? I am going to select the repeating variable as geometric variable. So I am going to select D as the geometric variable, and I'll write this as first repeating variable. First repeating variable. This is based on what? Geometric. Second is based on kinematic variable, so that kinematic variable which includes only time term, so that I'll select this as second repeating variable. It is based on kinematic variables. Then third is dynamic variable. So where mass should be included. In this, what is the term I am going to select is where the mass is included. I am going to select the variable which is having the unit of mass. So that, of course, mass is there here as well as here. Out of these two, only this is having mass and length term, but here mass, length and time is there. So that which for easiest purpose, I am going to select this as a third repeating variable, which is based on dynamic. So these are all the 3 repeating variables I am going to select. Based on this, we are supposed to write the number of repeating variables. What are the repeating variables we have taken? How many numbers we have taken? We have taken 1, 2 and 3. So that how to represent it. To write down the repeating variables, total number of repeating variables. It is denoted by small letter m. Total number of variables is n. Total number of repeating variables is m, and there are 3 repeating variables. So we are supposed to we are supposed to make a pi term. What is the pi term? Total pi terms. I can obtain the number of pi terms by using n minus m equation. This we are going to solve by using Buckingham's pi theorem. There is one more method called as Rayleigh's method. Thus Rayleigh's method is used only when the number of variables are 3 to 4. If it is more, 4, 5, 6 like that, we are supposed to go for Buckingham's pi theorem. So by using Buckingham's pi theorem, we are going to find out the pi terms by formula n minus m. What is the n we have taken earlier? We have taken n as 6 and m is 3. So we got pi terms. Number of pi terms are 3 terms. What does this 3 terms indicate? We have reduced the 6 variables into 3 pi terms. So that is easy to solve the problem. Next, by using this, I am going to write the pi terms. What are all the pi terms now? As I told, there are 3 pi terms. What are all the 3 pi terms? 3 pi terms are this things. Pi 1. Pi 1 is equal to, we are supposed to write the pi 1 by using first repeating variable. What is the first repeating variable? We have taken d, second is n, third is rho. So that I take pi 1 as d to the power of a1, n to the power of b1, rho to the power of c1, and which is the left out variable? The left out variable, one by one we'll write. The left out variable is, the first left out variable is q. So I'll write. Then similarly, second pi term, d to the power of a2, n to the power of b2, rho to the power of c2, and left out variable is q, which is left out, q is finished, and left out variable is gh. I'll take gh. Energy per unit mass. The third variable, third pi term, pi 3 is equal to d to the power of a3, n to the power of b3, rho to the power of c3, which is left out. The left out thing is power. So totally these are all the 3 pi terms I have written. Now we are supposed to equate these pi terms in the form of MLT, in the form of units, that is MLT. To do that, 3 pi terms for first pi term, it is pi 1, representing in the form of MLT, representing in the form of MLT. So what is the unit for pi 1? There is no unit, so that it will be m0, L0, T0. Mass is also 0, time is also 0, and length is also 0. For D, what is the unit I have taken for D? Unit is L to the power of A1. What is the unit for T? Sorry, what is the unit of speed N? That is T to the power of -1, O to the power of B1. The density unit is M to the power of 1, length to the power of -3 to the power of C1, and Q. Q unit is L3 to the power of -1. So these are all the units for pi terms. Now we are supposed to equate the units of pi term with respect to m, power of m, power of l, power of t. So how to do that? Equating power of m, l, t, both LHS and RHS. So for m, what is unit of m here? The unit of m is 0, left hand side. That is equal to, where is the m term? M term is here. The unit of m is C1. So that this is, the value of C1 is 0. Similarly for L, the unit of L on the left hand side is 0. That is equal to A1. Unit of L is here, minus 3C1. Again L is there, plus 3. Anyhow we got C1 as 0. Therefore this term will become A1 will be equal to -3. Then for T, again for T, left hand side the power is 0, other side minus B1 minus 1. Therefore P1 will be equal to -1. So using these powers to the above equation, let us say this is equation 1. Using value of A1, B1, C1 in equation 1. Equation 1. So what will happen? So that will be MLT L to the power of 0, that will be 0, same. M0, L0, T0, that is equal to L to the power of A1. What is A1? L to the power of A1 is -3. T to the power of -1. M, L to the power of -3, whole to the power of 0, and L cube T to the power of -1. So what is this one? This one we are taken as pi 1. This is pi 1. This term is pi 1. That is equal to, this term we are taken as D to the power of -3. L indicates 3. D. T indicates N to the power of -1. And this one indicates density to the power of 0, and this is indicating Q. So if I simplify this, what is a pi 1? Finally, we'll get a pi 1 as like this. Pi 1 will be equal to Q by N dQ. So this is the pi 1 term. So instead of writing these three variables, I can write as pi 1. Pi 1 indicates the combination of these three variables in the form of Q by N dQ. So this will be the procedure to determine the pi 1. Similarly, I'll give the answers for pi 2 and pi 3. By solving the same procedure, pi 2 and pi 3 will get in this way. Pi 2 will be GH divided by N square D square. This is pi 2. If we simplify the same procedure, I'll get the answer for pi 3 2. Pi 3 is equal to P by rho N cube D to the power of 5. These are all the pi 3 terms we got. Earlier the number of variables are 6. Now we have reduced those things to only 3 1. So further, if you give these variables to any of the analytical person, so that what they do, they will try to take only the pi terms, not the variables. So this is how we are going to group the pi terms. Now we have seen how to group the number of variables available or number of variables involved in a particular process or a phenomenon that we have seen here. Now each pi term indicates what? We got 3 pi terms for a particular problem, correct? Each pi term tells about, pi 1 term tells about, what is a pi 1? Pi 1 is equal to Q by N dQ. This is called as flow coefficient. Flow coefficient. And pi 2 is GH by N square D square. This is called head coefficient. And pi 3 is P by rho N cube D to the power of 5, that is equal to power coefficient. So these are all the, instead of calling it as a pi 1, pi 2, pi 3, further onwards I will call it as flow coefficient, head coefficient and power coefficient. So usually these coefficients are used for a particular topic, that is, this flow coefficient is always used for the problems where the centrifugal pumps is involved. That is, for pumps, we always use the flow coefficient. And for the turbine, we are going to use the power coefficient. And the head coefficient is used for both pump and turbine problems. What is the reason here I am using only the flow coefficient for the pump problems based on the pump? Because in the pumps, what is the output for the pump? The output or the main motor of the pump is to discharge the water. So in this, if you observe, the discharge is denoted by Q. Q is available only in the pi 1 term. So it is called as flow coefficient, and the main motor of the pump is to discharge the water. So that while solving the problem, always Q should be considered. So we are going to consider the flow coefficient with respect to the pump. Coming to the turbine, what is the output of a turbine required? The output of a turbine is always concentrated on the power developed, where the power term is available only in the pi 3 variable. So we are given this as power coefficient, and we are going to use this equation only for the turbine, only for solving the problem based on turbines. But coming to the head coefficient, we will use for both pump problems as well as turbine problems, because along with the power output for the turbine, head is also very important parameter. Along with the discharge for the pump, head, how much head it is going to discharge, that is also very important. So these two, the parameter head is important for pumps as well as for the turbines. So that it is very important to note that for the problem based on pumps, further onwards, any problem which is based on pump, we are going to use two coefficients, that is pi 1 and pi 2, because in the pi 1 we are concentrating Q, and in the pi 2 we are telling about the H. These two are very important for the pumps. Similarly, for the turbines, problem for the turbines, we are using two pi terms, that is pi 3 and pi 2, where pi 3 concentrate only about the power and pi 2 concentrate only on the H. So further in this chapter we are going to solve the problems based on pumps and turbines. While solving the problem, this concept is very important. If the problem is based on a pumps, then directly you can go with pi 1 term and pi 2 term. If the problem is based on the turbine, directly you can take the formula of pi 3 and pi 2. Similarly here, formula of pi 1 and pi 2 for pumps and pi 3 and pi 2 for turbines. Okay, this is the thumb rule to remember how to solve the problem for a particular case. If it is a turbine, the problem can be solved easily if you take only pi 2 and pi 3. If it is a pump problem, we can take the you can solve the problem by using pi 1 and pi 2 terms. Till now we have seen about how to make a group of variables into a proper manner and then to reduce the number of variables into the form of pi terms, that we have seen. Now we are going to see about the significance of those three pi terms. What are the significance of pi terms? We will see now. Significance of pi terms. So how many pi terms we have? We have three pi terms, where first pi terms tells about the flow coefficient, which is important only for the pump, that is Q by N dQ. Okay. What is the significance of the pi terms? Pi 1 term. The significance of the pi 1 term is if you purchase a centrifugal pump, there is some constant out of these three. That is, if a centrifugal pump is there with you, I can vary the discharge by varying the power supply or by varying the rotational speed. I can also vary the speed of the pump, but I cannot vary one thing, that is the diameter of the centrifugal pump. If you want to vary the diameter of the centrifugal pump, I need to replace the new pump. So with the existing pump, I can vary the discharge, that is Q. I can also vary the speed of a pump, but the diameter cannot be varied. So in this equation, let us consider this equation, and as I discussed, D is constant for a particular machine or a pump. For a particular pump, D is constant. If I keep the D constant in this equation and if I try to remove the pi 1 term, then what will happen? Q is proportional to the speed of the rotor. So this one is the significance of the pi term, first pi term. What is the significance of the pi term? Always the discharge from the pump is directly proportional to the speed of the pump. If I want to increase the discharge, proportionally, if I want to increase the speed of the pump, definitely I can get the more discharge. So this is called as first law of fan. First law of fan. So what the first law of fan tells? The first law of fan always tells about the Q is directly proportional to the speed of the pump. So this is the significance of first pi term. What is the significance of the second pi term? We will see now. The significance of the second pi term is pi 2 is equal to GH divided by N square D square. So again, this is the formula. So let us assume a turbine or a pump. In a particular turbine if I purchase, or a pump if I purchase, what is the constant I can take out from this? Which term I cannot change anything if I purchase a particular pump or a turbine. I can vary the head, I can also vary the speed, but the only thing I cannot vary is G. G is 9.81, that is constant, as well as the D, diameter of the rotor, I cannot change. That is, G is considered as constant, diameter of the rotor is also considered as constant. Then the above equation, I can rewrite that as H is directly proportional to N square. So for any pump or a turbine, the head is directly proportional to the square of the speed. Earlier we have seen pi 1, or the significance of pi 1 term is Q is directly proportional to the speed, but now it is understood that head is directly proportional to the square of the speed. And this is called as second law of fan. Second law of fan. Similarly, we will see the pi 3 term. Significance of the pi 3 term. What is the pi 3 term tells about? The formula for the pi 3 term is P by rho n cube d to the power of 5. Again in this equation, let us assume this is as I told earlier, pi 3 is only used for turbines. So in a particular turbine, if I purchase a turbine, what are all the things I can keep constant in this formula? I can keep a constant as density of the water I cannot change. It is always 1000. I can treat that as a constant. And diameter of the rotor I cannot change. I can keep this as constant. If I consider these two as a constant in this equation, then what is the relation between power and left out term? The left out term is only n. What is the relation between power and n? Power is directly proportional. I am removing the pi 3 term and putting a proportionality symbol. Power is directly proportional to the cube of the speed. So this is called as third law of fan. So now we understood about significance of each pi term. So what is the significance of first pi term? From the first pi term I understood that discharge is always, from the first pi term it is understood that Q is always proportional to the speed of the rotor, head is always proportional to the square of the speed, and the power is proportional to the cube of the speed. So if I want to increase the power, I suppose to change this. If I want to increase the power, I suppose to change the speed in the term of cube. If I want to vary the head, I suppose to change the speed in terms of square. If I want to vary the discharge, I suppose to change the speed only in terms of n. So that this is very important topic, or very important thing for the topics. Thank you.